Good morning friends. Today we are about to close, and in that we will be revealing our last topic on probability. So, generally the courses on probability and statistics are combined. Though this course is more towards statistics and applied statistics, still there is a need to understand what probability is, because ultimately when we go to statistics, it's more about application of probability and its consequences. So, we will not be going in very detail of probability, okay. Though the probability itself is a big field, and Bayesian statistics and those sort of fields have evolved from this. We will not go in that, but still introduction to probability is required for us to understand statistics. Okay. So, now we begin. So, what is probability? So, it's about an experiment or an event. Now, experiment and event, the difference is experiment is more controlled, event is not that much controlled. So, when I say experiment, generally we think of laboratories. Why? It means the variables or the external influences are not that much. Okay. Therefore, it is an experiment generally. Though we will talk about events also, but for the sake of this course, we can assume experiment and even synonymously event having more variables as compared to experiment. Okay. Then there is something called outcome. Now, there are multiple outcomes of an experiment, that is there. Okay. Now, the outcome primarily becomes what we are interested in. So, suppose I have a dice, okay, and I roll it 6 times or 1 time, let us say. So, I can get 1, 2, 3, 4, 5, 6, 4, 5, 6. Now, this is called a set of possible outcomes or sample space. However, outcome is what I am interested in, and we will go and understand things more clear. Now, statistically, what is an event? It is a subset of the sample space. So, as we told about this, that event and experiment are different. One thing is event, and event is having more variables as compared to experiment. Now, when we talk of an event in this in a probabilistic matter, it is about some sample space. Okay. So, an event has an outcome, okay, and we will come to that. It's not that difficult. We are not again going for probability theories and probabilistic models completely, but this basic understanding of probability is very important. So, we have a sample space which is set of all possible outcomes. Then we have an event which is a space subset of those possible outcomes, and from that, on those possible outcomes, we have outcomes. Okay, we will come to that. Now this is notification PA. So, first we have to define the event A, okay, probability assigned to each event A. And what is event A? Event A is a subset of the sample space called the probability of the event A, which will give precise measure of chance that A will occur. So, this is likelihood. Okay, let me describe to you what is sample space in a board format. Okay. So, suppose we can get 1, 2, 3, 4, 5. So, whenever we roll a dice, we can get 1, 2, 3, 4, 5, 6. This is our possible outcomes, all possible outcomes. Now, if we define the event as odd number coming up, okay. Now, as we all know, 1, 3 and 5 will satisfy this condition. So, our event 1, 3, 5 is subset of all the outcomes. So, there are 2 events, possibility even events, odd events. Okay. So, we will have 1, 3, 5 and 1, 3, 5 being specifically the outcome. So, there are 3 outcomes which will define this event. Okay. That is what an event is. So, event A, a odd number coming up. Okay. Now, as we talked about this, so if all are likely, or likely means let us say 1, 2, 3, 4, 5, 6 are likely. So, there is no biasness, and we will talk about that what is biasness means. So, biasness we will talk about it later. So, if it is all are equally likely, then the combined space is called sigma, this is one notation, and the number of events which we are interested in, that is called A, number A. So, in our case, the all possible events are 6 and the interested events are 3. So, probability of event A happening in our case is 1 by 2. That does not mean average second dice will be event A. What it means, when considered over a long time, like we throw it 100 times or we throw it 1000 times. If we throw it 1000 times, it is likely that 500 times we will get event A, or if we get 100 times, we will get 50 times we will get event A. So, this is what it means. This notation is very important. Okay. So, finite events which are equally likely, and we will go into that. Right now, let us assume it is equally likely. Okay, that is the denominator, and the numerator is the interested outcomes, or as the event we call. Okay, this is postulate. What is postulate? Probability of any event will be more than 0, of any event, okay, completely. Now, this is very important. If there is a space B, there are, let us say, 20 outcomes, 30 outcomes, we do not know, 30 outcomes, that we will not interested right now, maybe we can see that later, and you have spaces like this. Okay. So, B1 plus B2, B3, B4, B5. So, if B5, B1 plus B2 plus B3 plus B4 plus B5 is equal to B, then because probability of B, what is B? All sample space. Please understand, B is all events. Okay. What is the probability that we will get 1 to 6 on a dice? The probability that we will get either 1 or 2 or 3 or 4 or 5 or 6, a number from 1 to 6 on a dice, it is 1, because the sample space, the events which are happening 1, 2, 3, 4, 5 is the event itself. Okay. So, this will be 1, P of B will be 1. So, P of B1 plus P of B2 P of B3, P of B4 plus P of B5. This all is 1. Okay. And that is what we are getting. Now, there are n partitions, in this case we divided 5 partitions. Now, let us define in a practical example what it could be. Okay. Now, suppose I have marks 1 to 100. A student can get marks from 1 to 100. Okay. So, if I say he gets 90 to 100, he gets a A grade. If he gets from 80 to 90, he gets a B grade. 70 to 80, he gets a C grade. In this way, 70 D, sorry, this is 70, this is 60, D grade. Okay. Then 50 to 60 is E grade, and everything less than F, everything less than 50 is called F. Let us assume for the simplicity. Now, you can see that F have a range of 0 to 50, and again we are equally considering likeliness here. What it means, that there is no biasness. Teachers are not interested ki bhai everybody has to be given grace marks, or he is very lenient. If he is very lenient, then the probability of higher marks will be higher. If he is very strict, the probability of lesser marks will be higher. Okay. So, that is what we are trying to say, assuming that the teacher is very rational, or it is an objective test, we can say that, because in that subjectiveness it not there, the possibility of either too lenient or too strict is not there. Okay. So, in that case let us say objective marks. Okay. Now, if we say what is the probability of student getting grade F. So, grade F is from 50 marks or 0 to 49 to 50 events, okay, and it is out of 100. So, it is possible that every second student might get F grade. Now, again I am saying this is applicable providing that there is no biasness. In theory papers this is not happen. In theory papers most of the people pass. Okay. So, that means that there is endeavor to pass and those sort of things, and let us not get, it is not an equally likely event there. Okay. Here everything is possible, A is also possible, E is also possible with same effort. Okay. So, this is 5 by 10 and this is 10 by 10. So, 5 by 10 by 100, the 5 by 10, 10 by 100 is 10 by 100 plus 10 by 100 . Yeah. So, P of F plus P of E plus P of A, okay, they are equally likely. Therefore, I said, okay, that is the case. If it is not even equally likely, still summation of all probabilities of all events P of A plus P of B plus P of C is 1, but they are not equal. So, as we are assuming P of E is equal to P of D is equal to P of C is equal to P of B is equal to P of A, that is not there. Okay. So, please understand this is very important, either unbiased or biased, equally likely, unlikely, probability of all the sample spaces, okay, or of all the events which are different in the sample space is 1. That is what we mean here. Okay. P of all sample space is 1, this is what it means. Okay. This is very important. We are not going, this is from the Venn diagram concept of sets theory. We will just touch it little bit, so that if anyhow in statistics books this is used, you understand that. So, if this is a sample space B, okay, in that I say this complete portion is A, okay, and we know P of B is 1 in this case, as B is the sample space completely. So, and this is C. So, we will say P of A plus P of C is equal to 1, where P of C is equal to 1 minus P of A, or is also referred as a complement probability of A not happening. So, P of A bar is probability of A not happening, or as in this language it is written A C complement. Okay. So, please understand, for a given sample space, if you take one event out, even if there are multiple space, let us say we have A and C and D, then in this case P of A complement is actually P of C plus P of D. Okay. So, which tells us P of A plus P of A complement is equal to 1. Okay. Understood. So, इसीलिए कुछ होने का और कुछ ना होने का probability is 1. Okay. So, either you will pass or you will fail, the probability is 1, combining those events. So, if you pass, the passing probability is 40%, the failing probability is 60%. Okay. Now, that is a different thing, that you have grade A probability is different and grade B probability different. Then we will say, if the failing probability of grade F, let us say grade F in our case is something 40%, then summation of all other probabilities is 60%. So, I am not saying that C is always 1 minus C. What I am saying is, whatever is left out in the sample space, like in this case, A bar or A complement is P of C plus P of D. Okay? This is fine. Now, first rule is done. Second postulate. What we say, if suppose this is a sample space of B whether you can get 1, 2, 3, 4, 5, 6, and we say event A is getting a odd number, and then we say event C is getting a odd number divisible by 3. Okay. So, A is getting odd number and C is an odd number divisible by 3. So, we will say that P C is subset of A, P A, or A subset of, let us say A subset of C subset of B, C is subset of A and A is subset of B. So, for if you want to understand it more, there is called set theory and Venn diagram. It is very much elaborated there. We are touching Venn diagram little bit, okay, and there are lots of examples for practice. Okay. So, A is a subset of B. If A is a subset of B, then P A is a subset of P A is less than P B. Okay. If this is true, then P of C is less than P of A. Obviously, P of A in our case is 1 by 2 and P of C is 1 by 6. Okay. So, this is what subset. Now, this is very important. If A is a subset of B, please understand, if A is a subset of B, let us draw that. A is a subset of B, this is A. So, A is subset of B, then what does it say? Intersection. Now, please understand the word, this thing is called intersection. Okay. So, it say P and A complement. Okay. Now, please understand, we did say, let us understand this. If this is A and we can say this is C, so A plus C is equal to B. We say that? Okay. Now, we are trying to say intersection. Intersection means and. What is that which is common between B and C, that is C itself. Okay. So, if A is donated by these lines and C is denoted by these lines. Then P of B intersection C is C, okay, which implies that P of B is equal to P of A plus P of C, which we are trying to say again that P of C is P of C is P of B minus P of A. P of C can be written as P of B intersection A complement. Okay. Now, I will tell you one more thing called AND. Let us go in further slides and let us go to sets theory little bit, not much. Okay. If there is sample space A and there is sample space B, okay, A is represented by these straight lines and B is represented by so we have three regions. One is having straight lines, one is having this lines and one is having both lines. This is the intersection. Now, the interesting part is that this intersection is called P A intersection B, and as I say it is P A and B. At intersection both A and B will happen. Like what is the if the event A is, let us say sample space A is getting an odd number, okay, and sample event B is getting number more than 4. Okay. A is getting odd number and B is getting number more than 4. So, 4, 5, 6. Now, in this case A intersection B is 5, which is A and B. So, what is the probability of getting an odd number and more than 4? Okay. So, A and B. So, this is called A and B intersection. Now, in this frames comes second word union. If there is a and, there has to be a or. So, that is referred by as this upper you can say, or operator of intersection. This is A or B. Okay. Now, the interesting part is if you see mathematically P of A intersection B plus P of A union B is equal to P of A plus P of B. Okay. Let us give an example. In our case here, this is only what? A union B, A intersection B is only 5. Okay. And what is A union B? Either A or B. So, it is 1, 3, 4, 5, 6. See, now as 5 is getting repeated, hence when we add A and B, so 1, 3, 5, 4, 5, 6, we will get 2 5s as we are getting here. So, please understand P of A intersection B plus P of A union B is equal to P of A plus P of B when A and B are either intersecting or not intersecting or are not are indefined such way. Okay. So, this is what we were describing, inclusion exclusion. So, we can reverse it that ways. Okay. Now, this we have defined, this is very important and this is where our statistics will be using it and we will come to it more in detail. Okay. Now, so let us come to this example, a fair die is rolled on the number of top face noted, another fair die is rolled and the number on top is loaded. What is the probability? Sum of the two numbers showing is 5. So, please understand this. This is very simple example. Two dice are rolled. Okay. In one dice we can get 1 to 6 anything and second dice also 1 to get 6. Now, what is the probability of getting what we say 5? Now, first of all we need to understand how many possible combinations, the total possibilities. The total possibilities is dice 1, this is dice 1, let us say can get 1 to 6 and dice 2 can also get 1 to 6. So, in this way we have 6 into 6 possibilities. So, there are 36 total possibilities which is 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, 1 comma 6, 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5, 2 comma 6 in this way that till 6 comma 3, 6 comma 4, 6 comma 5, 6 comma 6. So, in this way we have 36 possibilities. Now, what is the probability that it is our event is the sum is 5, our event is 5. So, for our event what are the possible outcomes which we can have? So, we can have 1 4, we can have 2 3, we can have 3 2 or we can have 4 1. That is it 1 4, 2 3, 3 2, 4 1. So, we have only 4 possibilities. We are not having 0, obviously 5 0 is not possible or 0 5 is not possible. So, now we have only 4 possible outcomes. Which make our event, and as we know the probability of event A is number of possibilities of event 8 and divided by total possibility, this is 4 by 36. Okay. What is the probability? The second number, please understand, second number is greater than the first number. Let us take that. The second number is greater than the first number. So, how can that happen? When we have 1 2, 1 3, 1 4, 1 5, 1 6, okay, or 2 3, 2 4, 2 5, okay, and 2 6. 2 6 is also a possibility, 2 6. So, with 1 we have 5 possibilities, with 2 we have 4 possibilities, okay. With 3 we have 3 possibilities, that is 4 5 6, with 5 we have 2 possibilities, okay. With 1, with 2, with 3, with 4 and with 5. This divided by 36. Okay. So, that is the answer. Now, this is very important. How do we assign probabilities? Like, this is very important and we are going to use the frequency interpretation in our statistics class. But however, we also need to understand subjective probability. So, subjective probability is subjective probability. If I say what are the chances that today rain will happen? Now, this is based on my understanding. Okay, either I interpret or you interpret, the results might differ. I will say by 30% are chances, you might say it is 20%, or somebody else might say it is 45%, something. Okay. So, subjective interpretation is dependent on the person who is answering or who is evaluating. Okay. That is why we call it a subjective answers. It depends on the person who is writing. So, subjective interpretation depends on the evaluator. Evaluator perception of the event. Okay. Now, the frequency interpretation is what we have done till now. Here, either you evaluate or I evaluate, the answer is same. Okay. Now, we will come to an interesting concept here. Suppose it is just a fair coin, it is a fair dice. So, we will have 1, 2, 3, 4, 5, 6. Okay. These are the possibilities which are likely to happen. Now, if we repeat the observations, what will happen? They all are equal. Okay. 1, 2, 3, 4, 5, 6. Now, this is important. Now, if we draw the probability of these things, this will also be an equal likely thing. Which will be 1 by 6. Okay. Now, let us take a more realistic example. Suppose we are taking heights. Okay. We are taking heights of people more than 15 years old. So, we will have a category where the height is between 4 to 5 feet, where we have a height category 5 to 6 feet, 6 feet and above, and 3 to 4 feet and 3 feet below. Okay. So, less than 3 feet, less than 6 feet are two extremes, 4 to 5 is the middle one, 3 to 4 is also there, and 5 to 6 is also there. So, we are evaluating people who are more than 15 years old. Now, this is not an equally likely event as the dice was. There are multiple outcomes, there are 6 outcomes, there are 5 outcomes, 1, A, B, C, D, E. So, there are 5 outcomes possible. Okay. 5 possible outcomes A, B, C, D, E. Out of this, any one might come. Now, what will happen? Most likely, we might get something like, depending on our sample, that we have got 100 people here. Okay. We have got, let us say 200, let us say 80 people here. It is possible that you might get 120 also. I am just assuming 4 to 5 is the okay, and you get around 70 people here or 30 people here. Okay. Now, there are some possibilities that you might get people who are, let us say 3 to 4, less than 10 people, and less than 3 you might get some 2 or 1 people. Okay. Let us say 5 people. Now, having said this, if I say to you, or if I ask you, what is the probability that the person we select will belong to 4 to 5 feet category? He is between 4 to 5. Then on this basis of data, you will say the probability is 100 upon 100 plus 80 plus 30 plus 10 plus 5. This is the probability for this Similarly, the probability for D would be 80 upon 100 plus 80 plus 30 plus 10 plus 5. Okay. So, in this way what you have, same denominator, but the numerator is differing, hence the probability graph will also be looking like this. And we have some here and some here. Okay. Let's go back, let's check it out. Okay, there is some issue. Yeah. Okay. The probability graph will be equivalent to a frequency distribution. So, therefore, histogram which we have discussed is very important. Histogram give us the possibility of probability or the information about probability distribution. So, please understand, this is a histogram. This is a histogram. Now, when I draw probability of PA, PB, PC, PD, PE, if we add all of them, there will be 1, but their ratio of the bars will be as 5, 10, 100, 80 to 30, not length. It will be, let us calculate. Okay. So, 100 plus 80, 180, 180 plus 30 is 210, 210 plus 15 is 225. Okay. So, 100 by 225, which will be around 0.4 something, maybe. Let's check it out. Let's just use the calculator. Let's try it again. 100 divided by 225, 0.444 as we said. Okay. Now, we can calculate for 80 by 225, 0.35. In this way, this will be 0.44, this will be 0.35, and so on and so forth. So, the appearance of the possibility or probability distribution, probability of this events will be similar to the frequency distribution. Okay. So, with this, we will now go into week 2 and we will discuss multiple things, and I will be keep referring back to this lecture, this week 1, where we have discussed most of the basics. Okay. So, we have discussed in this week what is statistics, what is important of statistics, R keyword, little bit operation of R keyword. We have also discussed basic mathematics, and we have also discussed the basic probability which will be used for statistics. Okay. With this, I thank you very much and will hope to see you in next week.